A 200 amp non-fused disconnect can be used with a 225 amp panel that has an 80% rated main breaker, provided certain conditions are satisfied. Firstly, the panel ampacity must be considered. The electrical panel itself must be rated for at least 225 amps. This ensures that the panel can handle the potential load and provides a safety margin. Secondly, the main breaker ampacity is crucial. The main breaker within the panel needs to be rated for 225 amps, and it should have an 80% rating. This means that the breaker will trip at 180 amps, which is calculated as 225 amps multiplied by 0.80. This 80% rating is a common requirement to prevent continuous overloading of the breaker. Thirdly, the disconnect ampacity matters. A non-fused disconnect must be rated for a minimum of 200 amps. This rating ensures that the disconnect can safely handle the current flowing through it without overheating or failing. Fourthly, the conductors play a vital role. The conductors used to connect the disconnect to the panel must be rated for at least 200 amps. The conductors must be appropriately sized to carry the intended current and prevent overheating. In the scenario you presented, a 225 amp panel, a 180 amp main breaker, and a 200 amp non-fused disconnect, the requirements are met, making it acceptable to use these components together. The main purpose of a disconnect is to offer a way to isolate the panel and its circuits from the power source. This is essential for safety during maintenance work or in emergency situations. The non-fused disconnect does not provide overcurrent protection. It acts solely as a switch to interrupt the electrical circuit. Therefore, it is paramount that the main breaker in the panel is appropriately sized to provide overcurrent protection for the panel and its connected circuits. In this specific scenario, the 180 amp main breaker offers sufficient overcurrent protection for the 200 amp disconnect. This is because the breaker will trip if the current exceeds 180 amps, preventing damage to the disconnect and the rest of the electrical system. Consider the role of each component. The panel provides the housing and connection points for the breakers and wiring. The main breaker protects the entire panel from overcurrents. The disconnect allows for safe isolation of the panel. The conductors carry the electrical current between the components. All these elements must be properly sized and rated to ensure a safe and compliant electrical installation. To further elaborate on conductor sizing, it's essential to consult the National Electrical Code, or NEC. The NEC provides tables and guidelines for determining the appropriate conductor size based on the ampacity requirements. For example, NEC Table 310.15b16 provides ampacity ratings for various types of conductors based on their insulation type and temperature rating. When selecting conductors, it is important to consider the ambient temperature and any directing factors that may apply. Directing factors are used to reduce the ampacity of conductors when they are installed in environments with high ambient temperatures or when multiple conductors are bundled together. The goal is to ensure that the conductors do not overheat, which can lead to insulation damage and fire hazards. In addition to the NEC, local electrical codes may also have specific requirements for conductor sizing and installation. It is always best to consult with a qualified electrician or electrical inspector to ensure that your electrical installation complies with all applicable codes and regulations. When installing the disconnect, it is important to follow the manufacturer's instructions and use appropriate hardware. The disconnect should be mounted in a location that is readily accessible and free from obstructions. It should also be properly grounded to prevent electrical shock hazards. The wiring connections to the disconnect should be made with care, ensuring that all terminals are properly tightened. These connections can cause arcing and overheating, which can lead to equipment failure and fire hazards. Before energizing the electrical system, it is important to inspect all connections and components to ensure that everything is installed correctly. A thorough inspection can help identify any potential problems before they cause damage or injury. Once the system is energized, it is important to monitor its performance to ensure that it is operating within its design parameters. Over time, electrical components can degrade or fail, so it is important to perform regular maintenance to prevent problems. Maintenance tasks may include tightening connections, cleaning components, and testing the operation of breakers and disconnects. By following these guidelines, you can ensure that your electrical system is safe, reliable, and compliant with all applicable codes and regulations. A properly designed and installed electrical system will provide years of trouble-free service and protect your property from electrical hazards. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if you are not comfortable performing the work yourself. Electricity is unforgiving, and even a small mistake can have serious consequences. Take the time to learn about electrical safety, and always follow safe work practices when working with electricity.